Yeah. Good morning, everybody. It's a really great pleasure that the first session of this World Science Forum dedicated to the wonderful scientists who contributed dramatically to the earth sciences, but not only earth sciences. And today we have our exciting speakers to speak about the role of Laurent Eötvös in science and society. And I would like to, first of all, introduce my co-moderator. It's Katie Valley. She's a professor of the University of Edinburgh, and she's a president of the International Union of Geodesy and Geophysics. And myself, I am Alek Ismailzadeh from the University of it's called now Technical Institute, Karlsruhe Institute of Technology. It's very bad that I don't know the exact title of my institution, but it was University of Karlsruhe. And also I am secretary of the governing board of the International Science Council. And I would like to invite our first speaker and the panelists. First, it is Laszlo Sarka, who is the chair of the Eötvös 100 coordinating team. Laszlo, please join us on the stage. Then the next person is Joel Regai. He's a senior scientist from the Concoli Observatory. Joel, you are here? He was here just a few minutes ago. Okay, he will join us. And the next one is Lajos Wolyesi. He is a professor of the Budapest Technical University. Please join us to the stage. Come, you are welcome. And our panelist, Siert Kloting, he is a professor of the Utrecht University and the president of Academy Europa. Please, Siert, join us here on the stage. And now I would like to give... Yes? No, first. And now I would like to invite Catherine to speak, to introduce this session. Thank you.
Thank you very much. I will stand here because the microphone on the stage is not working. As Alek has said, I am the current president of IUG, International Union of Geodesy and Geophysics, or IUGG. And in that role, I wish to thank you most sincerely for the invitation to participate in this wonderful event in these magnificent surroundings. It celebrates the life, science and activities of Baron Laurent Eötvös, and please excuse my pronunciation, in association with UNESCO in the year of the centenary of his death, coincidentally also marking the centenary of IUGG. With its establishment as a General Assembly of the International Research Council, now the International Science Council, of which Alek is a member, IUGG brought together international societies with interests in geodesy, geomagnetism and electricity, meteorology, physical oceanography, seismology and volcanology. These subject areas now constitute 6 of IUGG's 8 international associations, with the other 2 covering hydrological sciences and the most recent addition, cryospheric sciences. Had Baron Eötvös been alive today, I'm sure he would have played an important part in IUGG, since he had wide-ranging scientific interests and was very active in fostering and furthering international cooperation and collaboration, which are essential ingredients of our union. We will hear about and see some of Baron Eötvös's interests and achievements in the course of this special symposium and at the exhibition to be launched tomorrow. And I do not wish to preempt those contributions. However, I would like to mention that one of his scientific interests was geodesy, loosely characterizing the shape and variation of gravitational on the Earth's surface. And he presented his results here in 1906 in London and in Cambridge at general conferences of the International Erdmessung, which was one of the international societies that was brought together to form the IUGG. We know him and his science now through terms such as the Eötvös parameter, the Eötvös effect, the Eötvös rule, Eötvös tensor, Eötvös experiment, and Eötvös number, some of which refer to his geodetic work, as well as features named after him on the Earth and the Moon, and planetoid 12301 Eötvös in the asteroid belt. Baron Eötvös developed a high-precision torsion balance, still one of the most accurate ways of measuring Earth's gravitational acceleration. This would go on to provide proof of part of Einstein's general theory of relativity. I first heard his name in relation to the Eötvös effect, which describes how gravitational acceleration changes when measured from a moving eastward or westward platform. Originally, the Eötvös effect corrected measurements of gravity made from ships, but now data are collected from helicopters, fixed-wing aircraft, and even satellites. We see the results of plate tectonics, such as mid-ocean ridges and subduction zones, reflected in marine gravity data, and they enable us to infer the strength of the tectonic plates. Gravity data are also used to explore for Earth resources, such as hydrocarbons and minerals. So the torsion balance and Eötvös effect have important economic implications. 2. It is perhaps fitting that the geological mineral named after him, lorandite, occurs in economically viable ore bodies containing gold, thallium, arsenic, and antimony, amongst others. I'm sure he would be fascinated to know that lorandite is now being used to determine the flux of neutrinos from the sun, enabling scientists to understand its nuclear fusion reactions. So, although I have concentrated on Baron Eötvös's geodetic work, it eclipsed the IUGG with which I'm familiar and had much wider-reaching implications. And he had interests that would have associated him with many other international unions that are around today. These include the International Astronomical Union, also celebrating its centenary this year, the International Union of Geological Sciences, formed more recently, but also with predecessors that date back to Baron Eötvös's day, and the International Union of Pure and Applied Chemistry, that collates surface tension data, another of his interests. He truly was one of our great polymaths. Events showcasing some of Baron Eötvös's work, equipment, and three-dimensional images here in Hungary and at conferences around the world are enabling a new generation of scientists to appreciate his contributions and understand better the history of our subject and how it has developed from Baron Eötvös's time through to the next century of achievement. Distinguished guests, Eötvös 100 honorary board members, ladies and gentlemen, thank you very much.
Thank you very much, Katie. And now I would like to invite our chair of the meeting dedicated to the 100 years anniversary of Eötvös, Laszlo Sarka, to give a presentation. Thank you.
So, I would like to give you some illustration about the life, on the life and the work of Laurent Eötvös, which has already been nicely summarized by Kati Váler. So you may use Roland in English or in any foreign language, or in Hungarian we write Laurent, Eötvös Laurent. Here some photos and painting about his life from when he was in different various ages. He was a contemporary of physicists Thomas Edison, Nikola Tesla, of Croatian or Serbian origin, Albert Einstein, and earth scientists Eduard Suess, Andrija Mohorovicic, and Milutin Milankovic. Central Europe played a very important role in earth sciences and physics that time. So this is the life of Roland Eötvös. He was a student at the Piarist in Budapest. Then he started law studies for only 1 semester, and he fell in love with mountaineering and started three-dimensional photography later and spent 42 summers in the Dolomites. He preferred to continue studies in natural sciences, so he went to Heidelberg and 1 semester spent in Königsberg. Very soon he was nominated as professor in Budapest at the university, which is named after Roland Eötvös nowadays. Was elected member of the Hungarian Academy of Sciences, was president of the academy for 16 years, was rector of the Pest University, nominated as Minister for Religion and Public Affairs, founded the Mathematical and Physical Society, became president of various tourist organizations, and his research work started with capillarity, surface tension of liquids, and then he changed for gravitation, gravity, and the related magnetism. The most significant papers are indicated, these 5 points. The black is the capillarity publication, and the light green is the laboratory, the physics publication. The darker green are the field related to the field measurements or geophysical measurements. He was nominated for Nobel Prize in Physics 3 times, but during the wars it was no chance to get for a Hungarian to receive the Nobel Prize. He was called as Prince of Physics by Einstein when he died, the father of geophysical prospecting when the 100th year of his birth was celebrated. Rankin wrote these words in the journal Nature. And Kati has already listed the 10+1 scientific terms which are named after Eötvös in capillarity, weak equivalence principle, laboratory and field instruments is called Eötvös torsion balance, gravitation on rotating planet, in geodesy, and in applied geophysics. And also the physical unix is has become again very popular in satellite gravimetry, satellite gradiometry. His significance in science that the Eötvös law in capillarity ranks with the university gas laws. He experimentally demonstrated the proportionality between gravitational and inertial masses with an extremely high precision. And the largest oil and gas fields in the first half of the 20th century were discovered by using torsion balance in Texas. The Spindletop Hill is very famous and established a leading role in economy of the United States. But his life and work are symbolized these 2 pictures, a glass of water, a metal coin remains on the surface of the water, and the Eötvös torsion balance. And you can see this Eötvös torsion balance, this double large unit downstairs in the hall of the academy. What is the significance of Roland Eötvös this year? For physicists, the Eötvös experiment is of crucial importance in modern theoretical gravitational physics. And we should not forget about a paper which was published on the 10th anniversary of his death. Sándor Mikola wrote that Baron Eötvös truths on gravitational force and surface tension will remain in 1,000 years as true and valuable as they are today, even when our actual concepts for gravity and for the smallest parts of the matter will remain to be eliminated. So theories arrive and will be eliminated, but the experimental physical facts remain forever. For earth sciences, what we learned during this commemorative year especially in and around the Carpathian basin, not only for Hungarian, but for Romanian, Slovakian, Serbian, Croatian geophysicists and geologists. Roland Eötvös represents a cohesion force among us. And for the World Science Forum, I'm deeply convinced that Roland Eötvös is an ideal of the ethics and responsibility. For the general public, I would recommend that he deserves to be a role model for the young generation in Hungary and in the world. Thank you for your kind attention.